You and we can do things which we couldn't do 10 years ago because of novel technological developments. Can I ask you, how do you see the development of the life sciences in your own research field at the moment?
Regarding the life sciences, I think, at least from my perspective, this is becoming more and more a data-driven science, and we are generating also, we ourselves, but also globally, are generating tons of data, genomic data mostly, but it's getting more and more also other data and other omics layers, where it becomes really interesting in the life science to not only look into one single layer of data, but also look how they are connected and how dynamic these different angles can be seen. I think this is something that will become more and more important, how to integrate such large data sets and really make sense of them.
Can you kind of summarize what are the challenges in the field now for the future, or currently and in the future?
I think right now, well, how to generate data has become a very easy task, and there are great service facilities for these things. But I think it's more important to find new ways of how to approach this data and how to understand the actual biology that is underlying. And I think this is the very, very big task, because you can see like generation of data becomes so cheap and is getting so fast. But what we really want to do is understand biology and understand the effects that specific states like diseases, but also especially health, can have on specific types of data. In my case, it's mostly microbiome data, but there are just tons of different levels. I think this is where we really need to focus on, to bring back the biological thinking into these big data fields, at least.
You are also part of Kiel Life Sciences, and this is a research focus. This is a strategic research focus of the university. How do you see your place there at Kiel Life Sciences, and is what it makes it so special and maybe useful? Is KLS there something which you consider as something special for you, or useful for you?
I think KLS just brings together different disciplines that are somehow interested in the same things, but from different angles. Like we have the university clinic that is involved on the one side, and this is very important for me, working with human health data. But also we have basic biological sciences, which are just so important to understand the general ideas and general changes that we see in these, for example, clinical data. And I think here Kiel Life Sciences really is the perfect setup to bring together people and to just nourish these interactions. And I think it's super valuable for the University of Kiel that we have something like Kiel Life Sciences as a research focus.
Is there a missing cornerstone in the Kiel Life Sciences where one, in terms of people or equipment or interaction network places or something, is there everything there what we need, or would you like to see maybe a bit new investment somewhere?
I think in general, Kiel Life Sciences already has a lot of these things that you actually need as a early careers researcher or young scientist to become part of a bigger thing. And I think the resources are already there, and also the people are just so approachable within Kiel Life Sciences that you can just say, yeah, I've been hearing about your research, and this just really fits very well what I am doing, or is an angle which I want to consider. So I'm very happy in Kiel Life Sciences and the research infrastructure that it provides.
It's what you are working on now and in the next few years. So your personal research agenda, what's up? Where you want to go?
My research is focusing mostly on the human gut microbiota. So the bacteria and other microorganisms that are found in the gut. And I think a very interesting angle that is still not completely understood is how does a healthy microbiota actually look like? I've been comparing the human gut microbiota to the gut microbiota of wild living African great apes, for example, to see how also evolutionary the microbiota has changed for a specific species and for humans, of course, in general, and specifically, and what are the impacts of environmental influences on the gut microbiota in a general healthy state. And we just see that the diversity also between individuals can be so large, and that the microbiota can just provide so many different functions to the host, that this is already a very complicated task to say, yeah, this is a healthy microbiota, because I think it can just be so much. But also in other projects, I now want to look into not only snapshots of a specific time point of the microbiota, but also how it behaves dynamically. So looking into longitudinal data, seeing how within a single person the microbiota is changing with environmental influences and also stressors. And I think here's also one of the key points in how to define a healthy, steady state, if you want. So, I think right here is where we really have to work a lot still, understanding what is the healthy, normal microbiota, and understanding why this is why a microbiota is contributing to health. Trying to put together this evolutionary perspective and the dynamics within a microbiota can just help us a lot in understanding the crucial role, and I think it really is a crucial role that the gut microbiota plays in health and then also disease, when things just start to get or start to fall apart, or just to change and perturbate this normal, stable state of the gut microbiota.
What is the future of the life sciences in general? They started from very specific. Now we are in the age of the big data. So where will they go in the future, in 5 years or 10 years? And also maybe you can also compare then, in general, the life sciences to the life sciences done in Kiel. What is your vision on that?
We see that this big topic of personalized medicine, at least in my field, is becoming more and more important, and really trying to understand what are the drivers of health in this specific person and where did things maybe go wrong. This is something that I think in general life sciences and especially human health associated life sciences are moving towards to. But I think also that the field broadens a lot, and I think there are just more and more different layers coming together again. And before, a lot was done, at least in the research that I did, based on genomics data or sequencing data. And I think now we really need to understand the how these different layers of biology are working together. So not only looking at the genomics and the potential, but also looking, for example, at more into transcriptional dynamics, into metabolomics, into metaproteomics in the field of microbiome research, for example. We need to find ways how we can connect these layers and how we can use these information to really understand those dynamics, and to, in the end, find the crucial points in these dynamics where we need to either maintain the status that we have to keep people healthy, or to understand where things went wrong and maybe being able to revert that, or even to prevent people getting to the point that they actually become sick. I think in the future is really collaboration, because nobody can do this alone. And and this brings me back to the point where Kiel Life Science can be the actual perfect, or the best umbrella for these kinds of studies, because we have those people who are really doing the in vitro experiments to pinpoint single changes and how they are affecting specific things. But also we have the big data approaches trying to find candidates which we want to investigate. And I think this is really where the future will be.